recording now. Thank you, Ajay.
So,
Hey,
hey, how's it going?
Sorry, I couldn't find the button.
That's cool. That's cool. Yeah, welcome and thanks for coming. And we'll make this quick. So if you don't have any more questions or comments or feedback, um, then maybe I can proceed with the session today. I've got my timer right in front of me just to make sure that oh good. So I'll share my screen. Entire screen. Sorry about that. You're seeing my screen now, right? Like as like any session, Ingramar, can you please maybe remind me if there's any questions I might not be able to see? Okay, so today we'll start talking about retrieval augmented generation. As I mentioned a little bit earlier, this is basically the heart of the study group. So if you don't attend to any of the sessions, this is the session to be in and watch. Maybe a step back a little bit. We kind of wanted to know exactly why we have to do a retrieval augmented generation, right? And we might have talked about it a little bit before. I think in module 5, if I'm not mistaken. So we set up our language model locally in LM Studio. We call the generator, right? So when we ask questions to our language model, the language model can only answer depending on its knowledge, right? So its knowledge is actually frozen the moment it was trained. So for example, September 2023, for example, it was trained, then it will only know things before that date, right? So for things like if you've got, say for example, new data that you wanna ask about from the language model, or if you've got private information like your private PDFs, right, that you want to ask the language model questions from or about, then with the current setup, the LLM cannot really reply to you intelligently. So what it does is it basically hallucinates, and that's, I remember Ingramar, you asked something about Code.Sydney to the language model, and then it basically just spit out some rubbish, right? So that sort of thing. But the good thing about the LLM, right? It's so confident, right? I wish I had its confidence, right? It can answer questions with the utmost confidence. So, but you don't really know that the answers are wrong. So, yeah, moving forward, that's what we want to build a RAG system for. That's basically the reasons. And to be able to build a RAG system, we need the LLM. So your LLM can be installed locally, like what we do with LM Studio, or you could actually use a cloud, an LLM which hosted by a cloud provider like Google or Anthropic or Bedrock, right? So you could use that if your system's too slow. And then of course now comes the vector databases, right? So we handled, or we started to discuss the vector database last week, and you might think that what's the point of discussing that? And we'll discuss it today. In the retrieval augmented generation system, it's basically just a simple RAG system we're going through, but it's the fundamentals that's important. Once you know this, you won't have any issues understanding the more complex ones. But before RAG, let's understand where RAG fits in the whole picture, right? So I stole this images from one of the AWS sessions I attended early this year, and we were basically talking about RAG, right? Like us, but they had to explain to us where the RAG system actually, fits in the whole picture. So, you've got this inverted pyramid, and at the top, the easiest, I guess, option to improve your RAG, your workings with LLMs, and in the bottom is the most difficult. So starting from the most difficult, the model builders, you can build a good GenAI system by training your own GenAI models, right? It's down the bottom of that pyramid, and it's the most difficult to do, and it's most expensive, right? So I haven't built a GenAI model before, and I don't intend to do anything about that. But many companies like Anthropic and OpenAI, they are part of that layer. Next one is fine-tune GenAI models. Sometimes there's ways to improve your GenAI system. This is more I guess possible for us to basically fine-tune our GenAI models, because these the companies that build and train the GenAI models, they generate what we call pre-trained models, right? Those pre-trained models that these people generate, we can actually fine-tune with our domain. So if we're in a medical field, if we're in a legal field, we can actually feed it some data set so that it knows all about our domain, right? So that's what fine-tuning is. We're not doing that, right? And then above the RAG is prompt engineering. So that's something that everyone can do. We can do it also if we want to. But the library that we use right now, Llama Index, Llama Index actually have a very good defaults in prompt. So initially, when you send a request in Llama Index, you don't actually see any prompts because internally it uses defaults, right? So if you want, it's part of the notebook. You could also display what prompts that Llama Index is sending to the LLM, right? So yeah, there's some improvements you can do with that, and it's easy because it's really just lines of code that you need to write. And finally, this is us here, Retrieval Augmented Generation. So we're kind of not the easiest way, but we're also not too difficult, right? So it's basically possible for us to do, and that's why we're discussing it now. Questions so far? Okay, I'll just continue. There's 4 slides here, so the third one is the most important one. But yeah, let's go. Okay, so let's discuss retrieval augmented generation, right? Before, when we set up LM Studio, we only had the number 2 here, the number 2 box, the generator, which is our LLM, right? From our, I guess, Llama Index interface, we just send a question straight to the generator, and then we saw that it hallucinates. Now, with the RAG system, there's a 2-stage process. The first step is basically to do a retrieval operation, right? And that retrieval operation means that we're actually retrieving something from the vector database, right? And the vector database, what we're doing is we receive the question from the user, and then we send it to the vector database. We want to retrieve similar items from the vector database, right? So imagine if you have your own PDF there. For example, you've got your resume, right? And you wanted to ask something about that person, right? So you ask about, okay, where did they go to college or to uni, something like that, or what their experiences in their employment history. Now, because we have ingested that PDF in the vector database, we can actually do a search, a retrieval of information from the vector database, and then we get the information back. When I say we, Llama Index, our application, and then once we do that, we can then send it to the LLM, right? So what we do is we send that's what we call the context. We're basically getting the context from our vector database, and then we send whatever context we get, whatever similar, I guess, chunks of text we get from the vector database, we send to our large language model for synthesis. So in Llama Index speak, we basically get all the related information from VectorDB, the context, and stuff it in the LLM request. And then the LLM will actually, the large language model will synthesize that with its, artificial intelligence, and then send back the answers in natural language, right? So that's what it is. The first step is retrieval, and then the second step is stuffing or putting all the context in and augment the request to the generator. Question?
Because I just want to understand, Gio, from the ingestion or uploading of the PDF side, I assume that database is after that, right? Or sort of like, I have a PDF, you have like a code to convert it into a vector DB.
Correct. So in the next slide, we'll see that there's actually 3 main steps in this RAG system. The very first step, before anything else, is basically data ingestion, right? And data ingestion means you basically navigate to your folders, where your PDFs are, where your, I guess, secret private information is. And basically that step is, you can do ahead of time, right? And do that as a batch script, right? And as a bunch of scripts that basically just ingest, read the data. We've done ingestion, right? In notebooks, we did ingestion using Llama Index, right? We did simple directory reader. If you remember that, we just pointed to the folder, and any file there, a PDF, markdown file, document files, text files, it ingests in the vector database in chunks. And then if you were able to set up your Postgres, you would have seen, how the chunks are ingested and how embeddings look like in the database, right?
Thanks, Gio. Yeah, honestly, I haven't done it yet, but sounds interesting. So you'll just let that script to manage the actual chunks inside.
Yeah. And then that script. For example, I mentioned that we have a separate ingestion script. You can be fancy, right? Like you can be manual and say, "Hey, I've got a folder, run it now," right? Or you can be fancy, like say, anytime a file gets copied to that folder, automatically kick off an ingestion. Or every time a document, because documents can be modified. It's a living document, right? You can say, every time that document gets modified, do an ingestion. We'll basically do an upsert, in our vector DB, right? So there's operations to allow you to do that. So that means even though the documents are regularly being updated, your vector database is up to date as well.
So one last question, Gio.
Okay.
Does that mean that essentially the language or the speak of RAG or LLM in general are all from the vector side of things, vector database side of things? Essentially, you cannot really do augmentation in a non-vector.
You can, right?
Oh,
So in this particular scenario, we are basically just doing a similarity search, because what we do is we want to basically ask questions about our document, right? However, in a real system, your data sources, right, can be multiple, right? So you can have maybe you want some of your answers to come from vector databases, from your documents. But on the other hand, you also want to have some answers coming from your relational database like your transactional systems, right? For customers, if you've got customer data, imagine you've got a chat. I've got a question about Engramar bolas, and then based on that question, it can actually get the data about Engramar in the database, and then get data about Engramar from the resumes stored in VectorDB. Yeah? So it can actually do that, not just the one. But in simple terms, yeah, if you want similarity search, yeah, it's from the vector database. Okay, I'll continue next. Actually, the most important one is the next one, not this one. So just an example on how a RAG system might improve your GenAI application. On the left is a system without RAG. So we don't have any context. We don't have any context. We don't have any similar or related information coming from our vector database, right? And at this time, it's asking, okay, which instances can I use with managed spot training with SageMaker? Actually, I don't really know anything about managed spot training, but I think what this is trying to say is when this large language model was trained, it had old information about managed spot instances, right? So, and it answered, managed spot training is subscription product available in the following instances, right? That one. But that's old information, right? However, if you have context or if you have RAG system, you can actually ask your vector database for, this relevant information. And the one in orange, that's actually the data coming from the vector database. So it's telling, so the question is this, we pass the question, create an embedding of the question, and then we send the question to vector database. The vector database returns with this context, right? And what we do is the context, the question, it actually sends it to the large language model for synthesis. And then based on that, the large language models knows that it can only get the answers from the context that you're supplying it with. And based on that, you get the answer in green. So that's basically, instead of, your language model telling you outdated information, it's actually telling you the right information based on what it extracted from the context. Question? Okay, 10 minutes. So I'll continue on the most important chart slide for today. If you want, I want you to memorize this slide, print it out, put it up on your wall, because once you understand this, that's it. You can skip the next sessions. Well, I hope you come back next week, but you can skip all the next sessions because this is the most important. If you understand this, you're good. You're good to go. Right. So retrieval augmented generation, everything you see here, that's what it is, right? There's three things: indexing or ingestion. Second one in purple is the retrieval. And the last one is the answering part. You'll notice always in a RAG system, there are two language models, right? We already talked about it before, right? The large language model for the retriever and the large language models for the generator, right? So the retriever is basically the embedding model, right? We've played with that, nomic, Hugging Face embeddings, right? We've done that locally. We've done that using the embedding model we downloaded from Hugging Face. And the generator also, we've tried different things. We've tried Llama 3.1, Llama 3, whatever we could download easily with LM Studio. So before anything else, right? Before you can basically talk to your RAG system, you have to do the ingestion part, the indexing. right? So we basically, in our case, used llama index to use a simple directory reader, right? Basically point it to a folder containing our documents that we want to index, and then basically run the load data, right? So basically ingest using llama index. Llama index, divides the document into chunks, into nodes, depending on the type of document it is, and depending on the configuration. And it sends the chunks, to the LLM, to the embedding model, right? And the embedding model, we know how it works. We send something to the embedding model, the text embedding model. It comes back with a vector, right? 768, 1048 length vector. And then once we have that vector, we persist it, put it in the vector DB, right? So this is our Postgres, okay? And if you've played with Postgres, you have a look at how the rows and columns look like. You'll see that there's a column for the text chunk, and there's a column for the embedding of that particular chunk. Okay, so that's our indexing, our data ingestion. As I mentioned, that data ingestion can be on demand. When you have a document there, run the ingestion, or on the fly. For example, when you update something, you can specify, or you can program it to run an update on the fly. So yes, after that, we've got our vector database ready. Okay, so next step is retrieval. Okay, so when you have a question, you send llama index your query, right? So that's your question text. What happens, right? So what happens is that text question, we send, when I say we, llama index sends to the embedding model, right? So the text that we send here, the question, it's converted into a vector, right? Why is it converted into vector? It's converted into vector because when we search our vector database for similar chunks or similar nodes, that's the only way that the vector DB can search, right? So vector DB doesn't understand really text. It understands text, right? So when you look for similar text in your vector database, you have to feed it vector, right? And because we have already converted our question text into a vector, we can easily do the vector similarity search, right? So once we do that, we get our similar, I guess, documents back, depending on our K setting. So top K, if you say top K is equal to 5, you get 5 documents back, right? Because, that's the 5 similar documents. Once you do that, now you're ready for the third step, which is the answering part, right? Okay, so once when we're sending our request to the large language model, now we have actually everything we need to supply the large language model, right? First is the context. And the context is nothing but the list of similar documents that gets returned from the vector similarity search, right? So these are all the contexts that we want to use, for the large language model. Now, I said that the question text was actually sent to the embedding model. It is sent to the embedding model, but it's also sent straight to the large language model, right? And finally, the prompt. The prompt is kind of sometimes forgotten in the context of llama index, because as I mentioned, llama index uses defaults for prompts. And with our example, we might need another part 2. Next week, we'll look at the example from start to finish, but we'll see how we can display whatever default prompts used by llama index. and it will basically make us understand, how things work. So we've got the context, we've got that question, and then we've got the prompt, and we basically send that, to the large language model, our LLM2 here, our generator. And yeah, that's it. The large language model will do its magic. Will synthesize the answer based on the context, the question, text, and the prompt. Mind you, all these are text, right? It's not vectors anymore. The LLM, the generator, is quite dumb. It only understands natural language, right? So the vector embedding is only used here, but once it's in here, all the input to the LLM is actually text, natural language. And then finally, it does its magic and returns back with a synthesized answer in natural language or in English. Hey, Tony, yes, go ahead.
Thanks, Joe. By the way, thanks for fixing the launching issue for me.
No
tricky. So basically, I got two questions. So
Yeah.
the first one, when we query the vector database, because I done quite a few experiments. So does it always return the full chunk, like chunk 1, 2, or?
Yes.
So it will not return like a subset of a chunk, but the full chunk.
No, it will return the full chunk. Yes.
Okay, got it. Oh,
yeah.
So second question is because I also read the paper you just recommend, because there is some limitation for the vector database. So for the next step, what do you think? Do you have any plan for applying like something like a graph rack?
For the cases of our study group, we'll just be basically doing this basic RAG. And next week, maybe week after next, we'll be talking about advanced RAG, but it's not really that advanced. It's just another step above this one. There are a lot of ways to do advanced RAG, right? And one of them is, knowledge graph type of RAG. Unfortunately, that's probably too much for our sessions. If there's interest, maybe we can build another a study group for that one, or maybe a presentation.
Sure. Thanks. Yeah. Answer my question. Thanks a lot.
Cool. I think that's all we have time for. I mean, if there's one last question before we go. So I think we'll just continue with the RAG next week, just going through the notebook that we supplied. So maybe we can play with that before next session, and try to as I mentioned, understand this page. This is the most important part. If you understand this, you're miles ahead of everyone.
Thanks again, Jo, for your time, and thanks, guys.
Thank you. See you next week. See you. Bye.
Thank you.
See you, Joe.
See ya.